Here is the first example. We're talking about first example in the AC power. So here he's asking about find the active power, reactive power, apparent power, and power factor in the following circuit. So basically he gave us RL circuit with AC source. How do I know AC source? The sinusoidal indicates that's AC source. Is this 120 volts is a RMS maximum, instantaneous, average? Always, this is always RMS value until unless I specify. Okay, we always take this as RMS value. Okay, now active power, what is the formula for active power? P equal to VI cos theta. Reactive power, Q equal to VI sin theta. And apparent power, S equal to P plus JQ, or cos theta equal to R over G. P, you can say P equal to I square times R. Q, you can say I square times XL. Okay, they will give you the same values. Now S equal to, when I say S equal to P plus JQ, that's a complex power. When you say apparent power, same as it's VI conjugate. Okay, and cos theta is R over C, or you can say P over S. They both will give you the same value. Okay, cos theta doesn't have any unit, but you have to say lagging or leading power factor. Okay, here to find PQS, I need to find I, or I can find cos theta. So to find anything I or cos theta, I'm going to find Z first. Z is nothing but impedance, which is 4 plus J3 right here. I'm converting that into polar format, 5 at an angle of 36.86. Converting polar format is nothing but R square plus XL square at the angle of tan inverse of imaginary over real. It is always imaginary over real. Now, once I find the impedance, I can find VI cos theta. So the supply voltage V is 120 volts. I current, so I need to find the current there. So to find the current flow in the circuit, I equal to V over Z, 120 over 5 at an angle of 36.86. That's 24 at an angle of minus 36.86. Now I found the I conjugate. I conjugate is nothing but 24 at an angle of positive 36.86. Okay. Now S equal to, I can use VI conjugate. Instead of using VI cos theta, what I did, or I square times R, what I did, I found the S value first. Okay, S equal to VI conjugate. V is 120 volt. I conjugate is 24 at an angle of 36.86. Okay, I think you shouldn't do that. Whenever you say VI conjugate, we have to use the only magnitude, not the phase angle. So it's look like I made a mistake here, but which is useful down the line. So when I say S equal to VI conjugate, I have to use only magnitudes 120 and 24. 120 times 24, that value is 2880. This is the right one. Okay, this is the wrong one. Don't use angles in the power calculations. VI conjugate is V times I, only magnitudes, which is 2880 volt ampere. That's the unit. I think I used the angle that helps me to I mean, it's look like a polar format. I can convert this polar format into rectangular format. That's how I got these numbers. But I highly encourage you, don't do this. If you are finding S equal to VI conjugate, make sure that you use only magnitudes. Okay. Now, so active power, as I mentioned, you can use the above formula. I have 120 times 24 times, what is cos theta here? I didn't find. Cos theta is R over Z. I have R equal to 4, Z equal to 5. That's 0.8 lagging. Okay, that's 0.8 lagging. Now, that's one way to do it. Or you can use P over S. Since I didn't find P, I can I'm going to use R over S. Now active power, P equal to 120 times 24 times cos theta is 0.8. So if you use 0.8, you can find that value. Or another way is active power equal to, I can use S times cos theta. Active power is S times cos theta. So if I use S times cos theta, still I'll end up with the same number. Okay. Reactive power is VI sin theta. Okay. V is 120, I is 24. If cos theta is 0.8, sin theta is 0.6. Okay. So that is around 1728 volt ampere reactive. Apparent power is, this is the apparent power, 2880 volt ampere. Complex power, as I mentioned, this is the complex power. Complex power is always P plus JQ or minus JQ if it is capacitive reactance. Okay, and the power factor is, I found it here, but I also already found it there, which is the lagging power factor. I'm saying lagging because it is it is inductive reactance. Okay, let me go with the next example. Here is the next example. Here I have 5 resistance, J3 inductance or inductive reactance, since it is in ohms, minus J5 ohms, that's capacitive reactance. This is always RMS value, 120 volt. Okay, what is the impedance, total impedance here? 5 minus J2, 5 point, I mean when I convert this into polar format, 5.38 at an angle of minus 28.8. Okay, so now even though it's RLC series circuit, at the end it is acting like a RC circuit. Okay, now what is the power factor? Power factor is nothing but R over Z. R, I have 5, Z, I don't know why I put 2, that's wrong. Z must be square root of 5 square plus 2 square. Okay, Z value is square root of 5 square plus 2 square, which is cos 21.8, which is 0.928 leading power factor. Okay, since this is minus J2, so totally it's a capacitive reactance, we will end up with the leading power factor. Leading is nothing but basically, when you draw the vector diagram, here is my voltage, the final current I totally is going to be leading at 21.8 degrees. Okay, that's what the leading indicates. In previous case, lagging indicates basically, here lagging indicates, here is my voltage and current is going to be lagging at 36.86 degrees. That's what the lagging indicates. Okay, so that's what leading and lagging tells you. Now here I found I equal to V over Z. V is 120 volts, Z is 5.38 at an angle of minus 21.8. So it is 22.28 at an angle of 21.8 degrees. I conjugate is, you will end up with a negative angle there. So I found the S value. Here also I made the same mistake. Please don't do that. I do not encourage that. S is always, it's a real number. It's 120 times 22.28. That's all. Okay, that S value is basically 2674.09. Okay, once I found S, I can find active power P equal to, can I say this S times cos theta? I already know cos theta value, which is 0.928. Reactive power I can find S times sin theta. Okay, so sin theta is, I mean from here you can find sin 21.8. So you can find the sin theta value. So active power is 2482.85 watt and reactive power is 922.05 var. Okay, we call that as var, volt ampere reactive. Okay, so these are the simple examples in finding power in RLC series circuits. Okay, next examples I'll solve a little bit complicated ones. Thank you.